Hi everyone. So we're going to go through chromatography really quickly today. So chromatography is essentially the separation of mixtures. So you have three different types. You have TLC, column, and then gas, and each of them have mobile and stationary phases. So mobile phase, obviously it moves. Stationary phase, it stays still. You need to know that the rate of separation depends on how the mixture interacts with the stationary phase and how soluble are they actually in the mobile phase. So with this in mind, with each of these ones, you have different sort of materials used for a mobile stationary phase for each of the different types of chromatography you have. So you have TLC, which is for mobile, it's liquid solvent, which an example of that is water. Your stationary is normally solid silica or alumina. And then you have column. Now, column's more specific to AQA, but again, it's liquid solvent, which could be water, and then solid silica and alumina. And then for both OCR and AQA, it's mobile is an inert gas. An example could be nitrogen or even helium. And then you have stationary, which is normally a microscopic liquid film. You also will need to know about something called the retention factor, which is basically your RF value. Now, personally, I never used to remember the equation. I used to remember the fact that it's always less than 1. So I used to kind of divide, and if my value was above 1, that was the wrong way around. And then I divided it so I would get a value below 1, and that was normally the way that I would remember it. But obviously, it's a component divided by the solvent. That is the most proper way. Then you need to know that with gas chromatography, it's a bit different. You use something called retention times because it's about how much the time has elapsed from the moment you actually injected your mixture to when it actually exit the tube of the chromatogram. So let's go on with thin layer. So thin layer is basically for small samples. So that's the most common one you'll see in exam questions. So with stationary phase, we talked about alumina or silica. It's basically works by adsorption. So they stick onto the surface. So the more interaction with the stationary phase, the more it will stick on the surface, which is what we want. We have our mobile phase. Now, it can either be polar or non-polar. Like dissolves in like, right? So we will look at what we generally have. And if it's polar, we could use water or an alcohol. And if it's non-polar, alkanes. Now, they could ask you, oh, how do you locate the spots? Or how would we see spots that are invisible? Because I've seen questions like this before. It's either UV light, ninhydrin. Now, the issue with ninhydrin is that it's carcinogenic, basically can cause cancer. And then you have iodine vapor. So I would pick UV light, though. That's the most important one that they generally use. You need to also know about how to kind of set it up. They could ask you the apparatus. So you need to basically prepare a beaker with a small amount of solvent, right? Because it's normally at the bottom. You have a thin layer chromatography where you have to draw a thin horizontal line with pencil. The reason why we use pencil is obviously pen separates, and that is your baseline. And then you place the pure reference, because obviously you want to compare what it is actually like to a pure reference, and then you can kind of indicate what it could be. Then you've got to allow it to dry with the actual sample that you want to see. You place the TLC inside the beaker with the solvent. Now, you need to make sure that the solvent does not cover the spot. And they place the lid to cover the beaker. That's like, I've seen a question where they've specifically said, like, what's the key point that you need to know about the solvent? And then they need to say that, well, it needs to not cover the spot. The solvent will travel up, and then obviously when it reaches the top, you remove the plate, remove the pencil line, and then you get where the solvent has reached, that's your solvent front. That's basically it in the gist. I would personally draw a photo or a picture just to so you can kind of cover all bases, and it will help you get some more marks. Now, column chromatography is AQA. Now, they don't go into much detail, but you need to know that chromatography can occur in a column, and it's basically a vertical glass tube, or in the lab, a burette is suitable, okay? You use an inert solid as your stationary phase, and that's placed in your column, as you can see. You also have a liquid solvent, which is your mobile phase. What happens is obviously they separate. The big thing about this one is that you need to know about something called the eluent. The eluent is basically when you have put your solvent in, it runs through the column, and what happens is it can dry out. So the eluent there is normally acts as a buffer to make sure that if you keep topping it up, so it doesn't dry, the solvent doesn't dry out essentially. So it's there as like a little buffer to make sure things don't dry out and it still passes through. That's kind of like the main thing you need to know about it. And I've drawn like a little picture. Hopefully it's quite right. Then you've got gas chromatography. So this analyzes gases, volatile liquids, and then solids in their vapor form. The stationary phase is a long cooled column, and it's a non-volatile liquid. So we talked about that. Also the mobile phase, so it's an inert carrier gas. They do ask you for example, so make sure you know it's helium and you make sure that you know it's nitrogen. Now this brings us on to retention times. They could ask you to read the retention graph. Now the retention graph basically is when your sample gets put in and then it reaches your detector, which your detector, for example, is like this little square bit in the middle of the gas chromatography part. It creates like sorry, the detector is like the little computer normally at the end. It detects like retention time values. What that basically tells us is the time taken for the component to travel to the column, and it also depends on the attraction between the solute and the stationary phase. It tells us basically a lot about how much it interacts with the stationary phase and how much quantity. Now, how is that relevant? Now, they could give you something looking like this, and you could get like multiple peaks, and they could ask you to interpret the peaks. So you could get like A, B, C, and then they could say to you, interpret which one is the one that has the most like interaction with the stationary phase. Now, the general rule of thumb is the larger the peak, so like this one, the greater the quantity of the substance. Okay, so that's how we know that there's a lot of A. That's what we know because it's the peak is larger. We also know that there's less of C because the peak is smaller. Now, if you look across, this is your time typically, the larger the retention time, so the further along you are, the greater the interaction with the stationary phase. So C would be the one that has a greater interaction with the stationary phase. That's what they typically ask for about chromatography. In terms of questions, it is just little nitpicky things about the things we just discussed. Typically working out your RF values, comparing them, checking the visibility, the retention times, reading things like that. So that's just chromatography in a general idea. So yeah.